Welcome everyone. Today we'll talk about the polynomial functions. And we have these videos also beside the videos of the function which I did for G11. So we'll have this, we'll add to your knowledge some points. What the meaning of polynomial? Like here, what you have here, what the meaning of the polynomial function? It's a power function, which is power for x equal 2 or 3 or 4. And the polynomial is not exponential. And at the same time, it's not a log function. So here, just think some facts to be remembered. First of all, a line like this, a vertical line, when it goes like this way and cut the curve of the function in 2 points, that means this is not a function. Because if it's a function, it will not cut it in 2 points. But this, we call it the vertical line test. As example, if I took a line like this right now, again, another line, and I will take here another line right now, and if I go this way, all the way down, and I will move this line right away into here, into this point, it cut in 2 points here. As long as it cuts in 2 points, it intersects with the curve in 2 points, that means it's not a function. A function cuts only if I draw a vertical line, it will cut or intersect with the curve in 1 point only. Curve or a linear or a line. So this we call it a vertical line test. These things are to remember. When we talk I want to remind you also that domain is for x and range for y. When we talk about x, it's the domain and range is y. This is the second point also. I just want you to know, guys. And here, as example, this function is fx equals x minus 1 whole square plus 3. Like you see it here, fx will equal x minus 1 whole square plus 3. As long as this is quadratic, because if we decompose this amount, it will be x squared minus 2x plus 1 plus 3. So as long as it's quadratic, quadratic means it's here into power 2. So if it's power 2, that means it will show me a curve like this, as long as it's power 2. In that case, x, because x here is the horizon, x is the horizon line. Let me just show you something. If I take this line like this, x goes here in this area. This is for the x. The domain of the x is this area, the horizon. So x here, like you can see, it can goes from minus infinite into positive infinite. No problem about this. No problem about it. Okay. Just now, we'll check out about the y. So here I can say x belong to real numbers, belong to all the real numbers. And I can say also minus infinite into positive infinite as well. Minus infinite into positive infinite. It's okay as well. But here, for the y, if you see the y here in this curve, I will just enlarge it so that you guys can see it properly. Let's go here and see the y curve. See the y. This is the y line, the vertical line. It didn't come from the point of 0 and 0. And it didn't come from it has no any intercepts with the x-axis. For that reason, we say started from 3. So y here is equal or greater than 3. Look at this here again. R equals when y belong to all real numbers with a condition or the term, a term. This line means a term that y is greater than or equal 3. The reason for this, like you see here, because we didn't start the y from the point of x 0 and 0 here. If we started from here, then y will equal 0 or greater than 0. But it started from 3, so I left 3 points here. 1, 2, 3. And so the y, this is the y-axis. This is the y-axis. So y started 3 or more. So this is the range of y when I write that. So don't forget, we said before that x is the domain and r is the range. And also I showed you in the other videos which I did how to calculate the range and the domain for all the types of functions. Okay. We're still reviewing back for some aspects. So the degree of the function is, when we say degree of a function, like here, what you can see in front of you here, let me just use another pen, a red pen, so that you can see it, guys, properly. Okay. The word degree of a function, a degree of a function, is the highest exponent. So what is the highest exponent here? What is the highest power? Forget about the word exponent. What is the highest power here? Power 3 or power 2 or power 1 or this 9x power 0? You know that x power 0 equal 1. So this is 9 multiplied by 1. Here, the degree is 3 because this is the highest. This is the highest power. The degree is 3. As you see here in front of you, the degree is 3. So this degree of this function is 3. We'll go to the next one. We also said we have something is called asymptote. The asymptote is a line that never intersect with the x-axis or the y-axis. It will never intersect with them, but it goes very, very, very close to it, but cannot be zero. Cannot be zero. We have vertical asymptote and we have horizontal asymptote. And just let me enlarge this as well, so you guys can see it properly. Here, you can see the asymptote here. Usually asymptote in the point which achieve the condition that x do not equal 0 and y do not equal 0. So here, when we come to see x does not equal 0. For that reason, we don't have two asymptotes, 1 divided by x plus 3. You can see here. So here, like I say, this is why the vertical line x equal minus 3 is an asymptote for this function. So x equal minus 3 here. When I go to the left here, I will go to the point minus 3. Then I will draw just, it's an illusion vertical line. There's no actually vertical line, just imagine it here. So this is asymptote. This is asymptote when x equals minus 3. Likewise, I don't think also for y will never equal 0. Okay, y also will never equal 0. So let's go back. Here we go. Just enlarge this one. And you can see here as well. That's why we have horizontal asymptote. This is the horizontal asymptote. When y here does not equal the 0, there is for line y equals 0. This is called horizontal asymptote. Okay, so here it will be. Simply y can be any other number, but cannot be 0. Y can be any other number, but cannot be 0. For that reason, we said 1 divided by x plus 3. And in general, usually there is a y asymptote of 0 when the degree in the denomination is larger than the degree in the numeration. Yeah. So here, this is a polynomial function. And on the figure, ax power n plus bx plus c, and so on. We say always we have a leading coefficient and we have a degree in any function. We have a leading coefficient and we have a degree. As example, let me say something here. Let me say here right now. Let me go here and say fx will equal x power 3 let's say here x, that is power 3 plus 2 x power 2 plus 7. I'll just enlarge this function so that it will be shown up to you guys. Here we go. So if I do it like this and enlarge it, let me do this like this now. 4x power 3 plus 2x power 2 and 7. So here we have something is called the leading coefficient, and usually we go with the letters LC, means leading coefficient, is here equal 4. The leading coefficient equal 4 here. And the degree of this function will equal 3. So the leading coefficient is 4, and as you see, the degree is 3. As you can see here right now, here, the leading coefficient is in front of the highest power for x. So the highest power for x is x power 3. So this is the highest power. In front of this power 3, 4. So the leading coefficient is 4. And the degree of this function is 3 because this is the maximum exponential for x, which is 3. It's another point. Let's go to the next one. Okay. Next point I just want to show you is how the figures looks like from when you see a curve or when you see a shape, you can forecast and say, this is a linear function, or this is quadratic function, or this is a cubic function, or this is quartic function, or this quantic function. How will you know that? How will you know that? How will I know about this? If I enlarge this figure just now, and I just want to see, so n equals 1 as example. When the power is 1, as example, it was 3x and 7 like this. If I say like this, a function like this, let's say a function like this right now. I have a function like this. 3x plus 7. So I'm expecting for this function that it is a linear. This will be a linear function. A linear means it's only one line. It will be only one line. It will be like, looks like this. It will give me one line only. Let me go and just share back where I am. So here, if I say as example right now, one line looks like this, guys. Just 1 second. It will looks like this. Draw. Let me give it draw. And here insert, and I will put just any draw unique shapes. Insert any shape. Yeah, shapes in here like this. And if the function was like this way, as example, so this is the linear. The function will be like just one line. So if we said this is a horizontal axis, if we have here the horizontal axis, let's say shapes here, And let me say that this was the horizontal axis and the vertical axis. Let me just graph it. Here we go. Yeah, I'll just draw it like this way. So here the horizontal, and this is the vertical axis like this way. Let's go like that way, sorry. And I draw another line. Here I go like this. And I will take this line just a little bit here and just take it from here and take it by that way. So this is a linear function. This is a linear function. This line is a linear function because this is 3x plus 7, which is a linear function. Linear function usually takes from the line, it takes a figure of line. Why? Because the power which I have here, x power 1. This x is power 1 actually. It's power 1. But we write it. We don't write 1 power 1. Okay? This is power 1. And here I will close it so that you guys know that this is a whole amount together like this way. So this is the linear function. In that case, it should be like what you see in front of you here. Okay. We'll go to the second figure of the linear of the functions, that is quadratic. Quadratic when n equals 2. When n equals 2. In that case, it looks like it's like, let me just graph it as well. So the quadratic, like as example, if I say as example, like here, we have here one for the quadratic. Let's go here. If we have an example, that will be fine. So quadratic, like here, if it n the x power square. So if I say like this, let's go for another graph. Let me say a function like this. I'll forget about this function and go to another function here. Okay, that's clear. Let me say 3x power 2. Okay, guys, here it is. Plus 2x plus 8. This is a quadratic function. This is a quadratic function. I'm expecting here that I will find a figure and a figure of a curve. So here, when I do this on a graph, we go now for the insert. Let me put shapes like this way again. And let me put the vertical axis. And let us go for another insert shapes also. And I will take horizontal axis. And here, if I just want to graph it, I will graph it in figure of, let me see here. Here is a line. It will look like this. Or a figure of a curve, like a figure of a curve. So it might look like this way. Then it goes also with another figure into another figure like this, or shapes. Let me see smart things like which is looks like, yeah, let's do this one. This figure may be more better to adjust it or to show it. CTRL plus Z, CTRL plus Z. Let me go to insert here shapes. And I just want something like the curve here. Yeah, this will give me a curve, I think. I think so. I hope so. It didn't give me a curve exactly, but okay. There is a part of the curve. And I will move this curve here. Then another part of the curve will be there. insert here shapes like. Now we'll take another part of the curve, another part of the curve, or do some figure like a curve. Nothing here for like a curve like. Anyhow, it looks like a curve, so it's you know, it will be this way as well. So I will put another one here, and I will connect it to it this way and take it just like a loop. Okay, here it is. Yeah, so here it looks like a curve a little bit, but I'll just enlarge it. Here we go. And I don't want this line. So that is another, so if there's a curve, more or less, sometimes it might be a little bit, if I have to take it that way, a little bit, you guys. A curve is also a kind of if not to lose the time, sorry about that. We can also do it like this way, but this is not a fully curve like. However, sometimes the curve is open than this, more than this. Like here is example, this is a curve, this is a curve. When the n equals 2, cubic n will equal 3, it will be on that figure. It looks like this figure exactly. N cubic 3. This is quadric when n equal 4, and this is when n equal 5. By the way, we can note also from the turning points. The turning points means what? When we have degree of 2, we will have only turning point, one turning point. Turning point means how the curve, when the curve will turn again, will make a turn. When the curve will, so 2 minus 1, we have one turn here. Here in the cubic 3, we have two turns. So this is one turn, here one turn, and this is the second turn, because 3 minus 1 will be 2. We'll have two turns. This is the first turn, and this is the second turn. So n here is equal 4, means degree of 4. As example, 3x4 or 2x4, x power 4, by other meaning power 4. So here I have n will equal 4, then the number of turns means the curve will change its direction. It will change its direction. So as example, it was going down, then it will go up. Then it will go down, then it will go up, like that way. So this term, the terms are n minus 1. So if I want to get any terms, I would say the terms, number of terms will equal n minus 1. That will give me the number of terms. So as example, if it was quadric like this, as example, let me say 3x power 4 plus 8 x power 2 plus 16. So this is now, the power here is 4. So I will say the number of turns, number of turns now, turns for that curve will equal, the degree here is 4. This degree is 4, so it will be 4 minus 1. So I will have here 3 turns for this curve. 3 turns for this curve. Like here, you can see it here right now. You will see it here right now. So as example, if it degree is 4, I have 1 turn, 2 turn, 3 turns, and that's it. Okay, guys. Same thing if it is more than 4, if n is 5, then I will have 4 turns. So I have 1 turn, 2 turn, 3 turn, 4 turns. Here it is. If you enlarge it, it will be appearing more and more. Like here 5. This is the first turn. This is the second turn down. This is the third turn. This is the fourth turn. We have 4 turns here. Okay. That is for the question is asking me here, what is the polynomial? What is a polynomial? We said the polynomial is having positive powers, and it's like even or odd that's okay, but as long as it's positive, that's fine. So gx equals n. No, this is not this trigonometric. fx equal to x power 4, that's right. This one also is right, because this is also polynomial. This one, no. This one is not polynomial. This is for a power, raised for a power 3 power x. X is not down. X is a power. So we call it exponential. We call it exponential. So no, this is not a polynomial function. It is exponential function. So this one, sin x or sin x, is a trigonometric function. This one is polynomial. This is polynomial. This one is polynomial as well. And this one is exponential function. And you can see the answers here. So this is polynomial. This is polynomial. This is not polynomial. This is exponential. And this one is trigonometric, like we said. The interval notation is where x lies between. Interval notation is where x lies between. So here I have interval notations between -3 and 5. So that means that x lies between -3 and 5. Okay, guys? So x is greater than -3 means it will move like this way. And with a maximum of 5, so it's this way. Okay, guys? So it's in brackets. The interval notation is -3 and 5. Okay. But also, I just want you to know that intervals that are infinite are expressed in the infinity. Like if we have infinity, round brackets indicate that the end value is not included in the interval. The end value is not included in the interval. So here, yes, here, when we come to see here, guys, we'll see that it's x is greater than -3, but it doesn't say it's equal -3. It is not equal -3. For that reason, we made it bracket like this way. But the other side is closed here because it is equal. So equal, we did this bracket. Just enlarge it and see more. Because sometimes when it's not very clear, you guys can see now we have two types of brackets. We have square brackets and we have round brackets. We have square brackets. This is a square bracket and this is round bracket. Why? Because here, the interval here, -3, x does not equal -3. X is greater than -3. X is greater than -3. For that reason, guys, we can't put it in a closed bracket like this or square bracket. The reason why, again, because x is greater than -3, but it's not exactly -3. For that reason, we put it around. It's around, like around a square bracket or round bracket. But here, no, it is closed in 5. So we have to put it in square bracket. The round bracket is always used at infinity and negative infinity. So we put in the round also for the infinity and the non-infinity. We have here square brackets, like we said, square brackets, and this is the square brackets, this one. And the round brackets is this one. This one also is used for the infinity. Is used also for the infinity. Just remember this. Okay. You show me 3 types of functions. As you can see, y will equal x. This is a linear. It takes a figure of a line. Here, y equal x square is a curve, like the curve which showed us just now. A cubic has exactly similar parts in quarter 3 and quarter 1. Quarter 3 and quarter 1. Let's go to for some facts here right now. We'll see some facts here right now. Now, y equal x, I have here x is power 1. For that reason, this is a linear, and it is represented in a figure of line. Like this way, it's presented in figure of line. Now I want you to watch. The domain is for the x and the range for the y. Let's go for the x. X got no limits here. It can go from positive to negative or from negative to positive. No control for the x. Any value. So it means minus infinity and positive infinity. So it goes from all the way from here till minus infinity until all the way here also to the positive infinity. This is any value for x. Likewise, there is no restraints for y as well. We said the x domain is x and the range is y. Also, on the range, no control, no limits, no restriction. For that reason, we'll find also for y minus infinity and positive infinity. Okay, the end behavior. The end behavior means what? It will start here. If we start from x, start from minus infinity, then we will start from this area. Then it goes into this way here. We call this is quarter 1 because this is a quarter. Quarter 2, this is quarter 2. This is quarter 3, this is quarter 4. Again, I would say this is quarter 1, this is quarter 2, this is quarter 3, this is quarter 4. So it goes like this is the end behavior, like what you see here. It starts from quarter 3 and ends in quarter 1. Okay, quarter 3 and end in quarter 1. Now we'll go to the second one, y equal x squared. Cool. Now we'll see, this is the figure of it. The power is 2, 10. For x, there is no problem. For x, there is no problem. Any number for that reason, minus infinity into positive infinity. But for y, no. Y does not go in the negative part down. It is 0 and above. So here I would say, because it's touching the 0 here, so I will put square bracket because it's definite on 0 and to infinity. Y can go anywhere here, up. Y can go anywhere up. And here it will start in quad 1, 2, and go to quad 1. Or start from quarter 2 into quarter 1. Okay, cubic. Cubic is power 3. It will give me a symmetry, like 2 parts of the function, 2 parts of the line. Exactly, this part is similar to this part, but one in the quarter 1 and the other one in quarter 3. And also, no limits for the x and no limits for the y, because we cannot do like here. Here we did for the y, we said it's starting from 0. For that reason, we put the y started for 0. You guys get it? X is here 0, 0 line, and y for infinite. Okay, that starts in quad 3 or quarter 3 and end in quarter 1. This is quarter 1, again, quarter 1. This is quarter 2. This is quarter 3. This is quarter 4. So we started in quarter 3 and ended in quarter 1. Let's go to the next page. Here, this is a quartic. The power here is 4. It is exactly, looks like the quadric. Let's go here and see. It's like the quadric. And the same start and end. And start also in Q2 and end in Q1. Quantic, YX5, it's like the cubic. Same like the cubic. So we have odd and we have and the 6 also is like the quadratic and like the quartic, the same thing. And the same also, the same. If you see here also, you will have the same, here it is, you will have the same ends and the same behavior, and the same behavior. So that was for the range, domain and range. And for the end behavior, where it starts and where it ends. So we can say the power 1, the open numbers, will start in quad 3 and go to quad 1. And we can say that the even numbers will start in quad 2 or quarter 2 and end in quarter 1. One thing more, the leading coefficient will tell me if there is any parts of this function will be drawn in the positive, negative area or no. And that's what we will see right now. Let's go for this example. Here it is. This is an example like if x equal to x4, this is the power is 4 here. So let's go take it one by one. Let's go take it one by one. Okay. The domain of the x's, any points here or any point here. X can take any points here or here. And we said that we will put round for the infinity. So minus infinity and positive infinity. And the range, no, we start here for the y from the 0. So here, x will be 0 and y will be infinite. So x here will be 0. Okay, when we graph it, it goes touching the 0, the x. So x here on the level of 0 and y infinite. We use the 0 here, square brackets, because it's determined. Because x here is 0. You guys got it? X here on the 0x. But let's go here for this one. Minus 3x squared. This minus, it should be like this one. If it was 3x squared, it will be like this one. But the problem is the minus. The minus put the whole graph in the negative area. Because any number here, it will be negative. You try it as example. If this x was 5, 3 times 5 squared means 3 times 5, 25 will be 75, and the minus is there. So all the graph will be in the area of the minus because of this minus. So I cannot do the graph on the area up. I have to do the graph down in this area down here. You guys got it? So as example, let me just explain it here. I will do just another graph, another figure, and we will see. Let's see. If I say as example, right now, let us go for a point like here. Let's go to another page. And here we have another page. Let me say here, and I get insert. And I will get the shapes here again. And I will put in the shapes here. This is this line, like this. Then I will put in the shapes also, draw this line, sorry about that, insert here as well. So I got here also in the shapes. I got this line, and this is the vertical. If the function start with, as example, let me see here, the function is minus 5x power square plus 7. Let's say like this. Here, the minus will make me do the graph down in this area down. It will be also power 2, means it will be quadratic. It will be a quadratic function, but the problem is not in this area. Never. Look at this. If this was positive, this, okay, I will do the positive one first. If it was positive, then it will go like this. Just 1 second, guys. We'll try this pen now. Here it is. it will go like this. Okay, that was if it was positive. But if it was negative, I mean by here we have minus. We have minus here. We have minus here, minus. Then in that case, wait. In that case, we will go like this now. Figure will be down because of the minus, because of this minus. This figure, the curve will be down. And it will go from lead 3 or quarter 3, this is quarter 3, this is quarter 3, to quarter, this quarter is 4. So it will go from quarter 3 into quarter 4. In that case, it will go from quarter 3 into quarter 4. That's how it works. That's how it works. That is for the points which I'm just talking about right now. Of course, the figure of trying to do approximate figures, but it's okay. So when you find minus, you will work in this zone area, down. When you find positive, you will work in this area, up. And that's everything for the moment for this part. Let's go right now, resume working on our own findings. What about the line asymmetry? A line asymmetry is like what you see in front of you here. A line asymmetry is a graph has line asymmetry if there is a vertical line, x equal a, so x equal a here is a vertical line, and that divide this graph exactly to two parts, exactly like the twin. Like this part, similar too much to this part, similar exactly to this part. This part here is exactly, looks like this part exactly. That we call it symmetry. Symmetry, S-Y-M-M-E-T-R-Y, symmetry. Means similar to. Okay. So we have line symmetry. A graph has line symmetry if there is a vertical line, x equals a, that divides the graph into two parts, such as each part a reflection of the other. Here, line symmetry, a graph has line symmetry if there is a vertical line x. That's I'm repeat back the same sentence, okay? The graph is often, this is repeated, so I'm sorry about that. The graph, here we go. Here we go. And this is another example for us. It shows also the quadratic and the same behavior when if it is from a positive also. We go from the positive to the negative constant from Q3 to Q1. But here we have from Q2 to Q4. That is if it was minus. Start because the minus will start from here, from this area. Then we will go down there. Okay. The point symmetry here. This is a point symmetry because in this point, both the sides are equal to the same. It goes the same. So if you see here, the graph of odd degree power function, the graph of odd degree power function have point symmetry about the origin 0 and 0. I don't want you to forget this. So if we have odd function, symmetry around 0 and 0. Symmetry will be around 0 and 0. That is if it is odd function. Odd, like as example 3, 2x3, 2x power 3. This is odd. 2x power 5. That's odd. In that case, it will have the symmetry around 0 and 0. That's the first point. Here as examples for some functions. And these are some examples. Another example. Here as example, this y will equal 0.5x squared. This is quadratic. The domain of the x from minus infinity to positive infinity here. The domain is for x because x can take any value here. But y? Y must start from 0 because we start here from the 0 and it can go to any values positive. Positive infinity. Okay. So x here is 0 and y is infinity. This is f of x. The graph extends from quarter 2 to quarter 1. As x go to minus infinity, like this, y will go to the infinity. Y cannot go down, so y will go to the infinity. Infinity for y is this. And as x goes to infinity, this x goes to infinity, y also will go to the infinity. There is no minus infinity for y. There is no minus. Line symmetry about the line x equals 0. So the line symmetry about the line x equals 0. Here, this is the line symmetry. Okay, the y-axis, here it is. Okay, this is the line symmetry. This is the line symmetry. And it is the y-axis actually, because it divides the two for the same. But it doesn't mean that all the symmetry, sometimes this curve might be a little bit up and still there is symmetry. Let me just tell you something. Let me tell you something. It can be like this. It can be like this. Let's see how it can be. Let's graph another graph here. Let's put another graph here. And let's say here as example, insert. Here it's the shapes. And I will take exactly just graph a figure like the figure which I did. And here also insert also a shape like this again. And here I will take this line. But it doesn't mean that symmetry must be exactly in this point. No, it was only in the previous example, but the symmetry sometimes might be like this. I will just show you. Draw. I will take a pen. It might go like this. And this is symmetry also because, but it didn't go down. It didn't go down to this point. It didn't go here. But in the graph which was here, in the example or in the exercise which we are working, the graph was here. For that reason, we said that the symmetry is about the line x when x equals 0. Here, when x equals 0. Because all around it. And the y line, the y line, the y-axis is the one who divides this figure into two similar parts. Let's go to this example. This is odd function because it's 3. And the leading coefficient is positive. So we'll move from the right here from Q1 to Q3. Right? And here, the domain of x, any point from minus infinity to positive infinity. Y, no constraints on y, no restraints on y. Y also has the values, the range also from minus infinity to positive infinity. The same thing. So as x go to indefinite, x go to indefinite, y will go also to minus infinite like this. And as x goes to infinite, y will also move to infinity. This is the points. So this is the points, guys. So this graph extend from quadrant 3 to quadrant 1. This is the quarter 3, this quarter 2, this quarter 1. So it goes from quarter 3 to quarter 1. Where is the symmetry? Around the origin here. This point, 0 and 0. When x equals 0. We'll find the symmetry or the symmetry in the point 0 and 0 here. Because this point divide the two shapes, two similar shapes. In this part, I just want you to understand the question of the function. What do we mean by the function? What's the importance of function? Because function always measure two variables that they're both changing. One value for x correspondence for one value of y. Give an example for the function, like if we say now the price, the quantity and the price. This is an example for the, so the quantity is affected by the price. If the price go up, the quantity will go down. If the price go down, the quantity will go up. Both of them are changing. The quantity is changing and the price is changing. This is why we call it a function. Degrees even because it looks up, and it's also, we can know from, we have three turning points, 1, 2, 3, plus 1 will equal 4. So we have here even. And the leading coefficient is positive. Why? Because it's in these two areas. It work on the upper part. It didn't go to the second down part here. No, it didn't start in the yes, part of it is down, but this is not the, it should be the start itself. Okay, but from Q2 to Q1, and the number of turning points we have 1, 2, 3, because it's 4, it's even and 4. Its number of intercepts is 4, and the possible degree is 4. So in that case, because 1, 2, 3 plus 1 is 4. So, and it's positive. The leading coefficient is positive. Okay, number of intercepts. How many intercepts I have here is the number of the degree itself. The number of the degree is the number of intercepts. If you look here, you will find the number of intercepts or the number of the least possible degree. The intercepts equal the degrees. Always like this. Always like this. So the intercepts equal the degree. Intercepts equal the degree. The turning points are less than the degree and less than the intercepts. So you find 5, 5, 4, 4, 5, 5, 3, 3. Okay. Number points are less 1. So here 4, 4 minus 1 is 3. The turning points are the number of the degrees, the degree 4 minus 1 is 3. Degree 5 minus 1 is 4. Degree 4 minus 1 is 3, and so on. Is there a symmetry here? Actually, nothing here with symmetry. But the only thing here, the last shape. The last shape, there is a symmetry, which is point here. This one. Yes. But the other figures, there is no symmetry. Even you can see it from the figure itself. It doesn't show two portions or two parts are similar to each other. But here, we have two parts similar to each other, especially in this point. Because in this point, this part will be similar to this part. Here, from here, this part is similar to this part. But they are all like adverse. Okay? And here, the similar is a point here. Okay. So this is another example and another exercise how we can do the functions and all the treats which in the functions as well. So here This is x4, x power 4, so the degree is 4. The sign of the coefficient here is negative. So I'm expecting that the draw of this curve will be down, not up. So it will be quick. As long as down in the bottom part, then it will go to quit 3, quarter 3, and quarter 4. Guys, again. We said what will control the graph is where if the minus, the leading coefficient, here it is. Just 1 second. Here it is. Look at this. The leading coefficient is minus. The leading coefficient is minus. For that reason, here, when we graph it, it will be in this area. The start from the minus. So it will be in the minus area. So this is, and also its degree is 4, so it's even. So that means it will be here, guys, like this. It will be here like this. I will just draw it as example here. Take a pen and just draw it. It will be in this area that way. Here, it will be in that area that way. Okay, quarter 3 to quarter 4 and ended in quarter 4. Okay, and that's here it is. Even quarter and the behavior quarter 3 to quarter 4. Possible number of turning points 4, as long as this is 4 power 4. So I will have till 3 turning points, but I will have odd number. So I will have 3 turning points or 1 turning point. Possible intercepts, it will take the same thing. The possible intercepts, it will take the same things, 4, 3, 2, 1, and 0. Okay, next one. 2x5, this is positive. The power degree is 5. So I have turning points of 4, but this time it will be even. It will be even 4 or 2 or 0. So I might have 4 turning points or 2 turning points or no turning points. And here it's odd. Odd means from Q3 to Q1. Positive, so from Q3 to Q1. Here, px equal 4 minus 5x squared plus 4x minus 5x plus 4x squared minus 3x cubic. So what? What is the degree here? 3. The maximum power of x is 3. And the leading coefficient of this 3 is what? Is minus. It's odd function because 3. Yeah. And it's negative or positive? It's negative. For that reason, I will move from Q2 to Q4. Number of turning points, it will be even. 3 minus 1 is 2. 2 or 0. We cannot say 1. With the intercepts, with the turning points of the odd number, it will take n minus 1 means 2, and it will be even numbers. And for the even numbers, it will be minus 1 means 3, so it will be 3 or 1, but can't say 2. So in the even cannot say 2, and in the odd cannot say 1, like this one. Here, if I just say x times 3x times 4x, that will equal times 2x, x means x degree 4, even without completing it and factor it. So x would be 4. Then the factor here is positive, and it's even. Yeah, even and positive. So I will move from Q2 to Q1 because it will be on the positive side here. And the number of turning points, 4 minus 1 is 3. And I will take only the even numbers, which 3 or 1. But the intercepts will take all the way down. So the intercepts will be 4, 3, 2, 1, 0. That is, so in the 4, we see here the intercepts 4, 3, 2, 1, 0, 4, 3, 2, 1, 0, in the 3, 3, 2, 1, but there is no 0. And the 5, 5, 4, 3, 2, 1, but no 0. So in the odd numbers, there is no 0 for the intercepts. For the intercepts, there is no 0. This figure show me the degrees and how to get the degree. The first degree, how we will get it? Guys, it's very easy here. We get the y, and we will take the numbers minus 16 minus 45, that will give me 29. Minus 3 minus 16 will give me 3 minus 3 plus 16, that will equal 13, and so on. So this is the first degree, or the first difference. Then again, we'll take these numbers and play the same game. So 13 minus 29, that will be minus 16. 3 minus 13 will be minus 10. Minus 1 minus 3 will be minus 4. 1 minus minus 1 minus minus will be positive. So 1 plus 1 will be 2. 9 minus 1 will give me 8. 23 minus 9 will give me 14. This is the second degree. I'm looking for similar numbers. When all the numbers are the end similar, then we will reach it to the degree. So this is the first degree, this is the second degree, and I notice that the numbers are different. They are not all the numbers, but look now when we get the third difference between the numbers. Minus 10 minus 16 means minus 10 plus 16, 16 minus 10, that will give me 6. Minus 4 minus 10 minus 4 plus 10, that will give me 6. 2 minus 4, 2 plus 4, that will give me 6. 8 minus 2, that will give me 6. 14 minus 8, that will give me 6. Wait a minute. Now all are similar. So we can say now that this function degree is the third, means x power square. Okay, now I want to get the value of a. I would say 6. This 6 will equal a 3 factorial. So 6 a factorial. 3 factorial means 3 multiplied by 2 multiplied by 1. Just 1 second. Let me just do it for you here. Here, 3 factorial will equal 3 multiplied by 2 multiplied by 1. So this will equal 6. So this is the way it is, like this way, factorial 3. So this will equal like here. I'll go back to it. 6 will equal a. I just want to see a, how much it will be like, because I want to see a, or the, by other meaning, a is the leading coefficient of the highest degree. How I will get it? I will say 6, which is this number, will equal a 3 factorial. Why this is 3 factorial? Because this is the third degree, second degree of third degree. Then a will equal 6 divided by 6, a will be 1. So this function coefficient, leading coefficient, was 1, which means we don't write it. We don't write it. Okay, guys. Shall I stop here for the moment? Then we'll resume back working on the next lecture. But here also there is state the degree of polynomial function that corresponds to each constant's finite differences. Then determine the value of the leading coefficient for each polynomial function. So if I say second difference is 8, so the degree is 2. This is minus 8. So minus 8 will equal a 2 factorial. So minus 8 will equal 2 times 1, which is 2. So a will equal 2. 8 divided by 2 will equal minus 4. Same like was for the other one. This is another example exactly like what we had here, the same, but this is the degree here is 4 because the numbers become similar in the fourth degree. When we subtract the first one, was not similar. These numbers are not similar. Then when we get the second differences, it was not similar. When we get here the fourth differences, it was similar. 1, 2, 3, 4. So I have here now this number will equal a y factorial or 4 factorial because here 1, 2, 3, 4 factorials. And the number of that similar number is minus 24 will equal a. I'm looking for the constant. So here 4 factorial will be 4 times 3 times 2 times 1. 4 multiplied by 3, 12 by 2, 24. So here minus 24 will equal 24a. Then a will equal minus 24 divided by the 24. A will equal minus 1. So that is for the moment, and we will stop here on slide number 46 and resume working on the next lecture. Thank you so much.